Good morning, Video Land. Here it is, Wednesday, and we're looking at day 4 notes where we have a picture that looks like this, representing snapshots of a spring. Is that showing up, Alex? Is that showing up?
Yes, it is. Yep.
All right.
There you go. Look at that.
It's representing a spring that is going up and down, snapshots from where we pull it down, release it, and it takes on that pattern in its flight. So, looking at our work, it looks like we have maybe today, tomorrow, and at last, I figure Friday I'll tack on in case we didn't finish something. We'll be done this mod. So, how's Tuesday? We have a short class on Friday, right?
Yep.
So, we won't accomplish a whole lot.
Oh,
So,
man.
review Monday, test Tuesday. What do you got on Tuesday other than that? Anything of importance that would cause me to slide it up or back? Zach, did you say anything?
I don't think so.
Okay. Anyone else? Speak now or don't speak. Alright, so if you would please note that I'm aiming at a test on Tuesday. I'll know perfectly sure by the end of this week. So, alright, we're going to complete our... It worked? What'd you do?
You just have to take it, you take this part off,
Yeah, I did that.
and you just take the scissor and you're going to pop it. It's going to feel like it pops
I
out.
need that.
As soon as that happens, it's fine. As long as you just use this side.
Yeah, I do. I tried to. Probably did one time. Thank you. Alright.
Oh yeah.
Alright.
It's like the Bel Air version.
Alright, we're going to finish the map. So let's go ahead and remind ourselves what we were actually mapping. And what we were mapping
Sometimes
was
it's
velocity
fixed. It's like every day
and
now. It's like,
acceleration. So I'll write it down here. I didn't leave myself much room.
Ready for takeoff.
So I'm
Captain Check
wondering, as I'm sure you are
Go to
as
the wing.
well, what is happening to velocity and
5,
acceleration at
4,
each of these spots? What are you saying, Alex?
It sounds like the airplane's taking off, and I'm like, get ready for takeoff.
I wonder what they hear with that.
I probably can hear it because it's really loud.
I know, maybe I should ask you to videotape that you're right under it.
Engine
Well,
spinning up.
That's the way it is in here, so they'll have the same experience as we do. Alright, so the velocity and acceleration we are mapping across, and I wanted to make note that F equals MA, that's an old friend, and F for the spring is negative KX. I'll point those out to help us in our mapping chores. Alright, so we pull this down. What's this distance called when I move it from equilibrium to the furthest spot away from equilibrium that I'm going to pull it? What is that, MD? Amplitude. So, alright, so when I pull it down here, right when I release it, we established yesterday that velocity is 0 and acceleration is at the max. So I guess we started, what, 2 minutes ago? So around 8:20, we'll shut it down for the next part. Not 8:20, 8:40. So someone remind me if I don't think of it. Alright, so we got that far. Now, when I release it, let's go around and see if you can figure this out. Zach, you're up next. What happens to the velocity? I said it was 0 here. So is the velocity going to increase or decrease as it continues up? Pardon?
Decrease.
Velocity is already at 0.
Oh, wait, that's it.
It's going to increase. So remember, when I release it just for a second, it's 0. So as it goes up, we're not laughing at you, Zach. So velocity increases. All right, I'm putting the whole word there, but you can just put increases. We're up to this one. Velocity increases.
Can we put a plus?
Yeah, whatever speaks to you. All right, I'm putting the whole shebang out here because I'm the teacher, but you're taking notes that you will have to understand later. All right, now acceleration, MK. What is going to happen to acceleration And let's talk a little bit about why. If it's at the max, that kind of gives you a clue that it's going to what? Increase or decrease? Right, okay. So we don't have to laugh at you. All right, so acceleration decreases, but let's look down here and see. Remember, we learned yesterday that force and acceleration are best friends forever, BFF. Whatever force does, acceleration does. So here from the spring, we know the spring law, Hooke's law, that as I released it, this distance, x, went down because it was at its max, and now the distance went down. So this value went down. That means force went down. That means acceleration went down. So that's another reason why we say acceleration decreases. So whatever works in your mind, make sure you can establish that that's what happens at this position. All right, now it goes back and it hits the blue line. What's the blue line, Alex?
Is equilibrium.
Right, equilibrium. So at that point, what do you think is going to happen to velocity? It was at 0, it increases, and what do you think happens there to velocity, Alex?
You said it's increasing?
It does. In fact, it's at its very max right there. And acceleration, look at the path it's on, Alex. It was at a max.
So now it says minimum?
And yep, it is. So let's see if that makes sense. So we'll say, and not only is it a minimum, it's at 0. So acceleration is going to again follow this path. Whatever force does, acceleration does. So over here, Alex, how far away from equilibrium, that's the x, how far away are we at this position?
Pretty far.
No, from equilibrium, how far are we?
Oh no, we're actually right there.
We're right at equilibrium.
Oh.
So there's no distance between equilibrium and this position. Does that make sense?
Yeah.
So the x is 0. So force is 0, and best friend acceleration is 0. So somehow we have to get this pattern down. All right, because it's not accelerating at this point, but it has a velocity in this direction, it's going to keep going. So we learned in the past, I think mod 2 or 3, that if velocity and acceleration are in different directions, it slows down. And we learned if velocity and acceleration are in the same direction, either up or down, like that, then it's speeding up. So, at this pace, we know that the velocity, the spring, we can see it, it's going up. So velocity is up, and acceleration is going to mimic whatever force is. Because this is a restoring force, which way is that force going to be, at this point? Because it wants to get back to where?
Equilibrium.
So the force has to be in which direction? If the right. So the force is this way, and so at that point we are going to have the force is down, and the acceleration is going to mimic it. Remember, it's going to be in the same direction. So she said the restoring force is down. That gives us the clue that acceleration is also down, and velocity is up. So we have this situation, we have one going one way and one going the other. So all that to say, what is velocity doing?
Decreasing.
Decreasing, all right. And acceleration, because it's mimicking what the force is doing. There's now an x, so what's happening to acceleration?
Is it also decreasing or is it increasing?
Well, we were at 0, so it's going to what?
Increase.
Yes, so it's increasing
Oh my
because acceleration is increasing here because force is. And force always increases when there is an x, a distance between the mass and the equilibrium. Alright, Brian, this thing is gonna come to a point where this spring is coiled up as much as it can be, and at that point, we are at equilibrium again. I mean, not equilibrium, we are at amplitude again. So this, provided there's no friction in a frictionless world with no air resistance, this amount down will be repeated on the way up. So this is amplitude again. It will in real life be a little shorter than that each bounce, but ignoring that fact, which we like to do, and we don't like the facts, we just ignore them. So, all right, Brian, what is happening at this point to velocity? It was at a max, and then it's decreasing, and when it gets to that point where the spring can compress no further, what's happening to velocity? It is.
I have
We're
a
at-
question now.
Uh-huh.
For the second one you labeled, the V increases, A decreases. How can something be? I mean, the acceleration is decreasing, so it's not speeding up.
Right.
Okay, I thought that meant like it was decelerating, which means it was slowing down.
Yeah.
It was kind of weird.
I know, it is, when
Yeah,
you
it's
try
just
to
not
put all the
speeding up.
pieces together at once and do rattle your brain. I agree. So, alright, so, Brian, and you said velocity is 0. Look at the path acceleration was on 0, increasing. Remember, it's going to be tied to what force is doing, and we have a largest x. So what's acceleration doing?
X, that means A is, I guess that is maximum.
Yep, back at a max. Coming around the robin here, we have MD. We're coming back down, and this time we have seen, let's do velocity then. What's going to happen to velocity? Since we were at 0, is it moving? Yeah, it's increasing. It is increasing in the negative direction, but we'll still call it increasing. All right. So we won't confuse the issue of which way. A negative number you might say is not larger, but we'll say the absolute value of that number is velocity is increasing. So MD, acceleration.
Oh my gosh, oh, he's dropping.
Right, it was at a max, and the reason it's decreasing is because of force.
It's force.
Force is decreasing because that x is getting smaller now. So, decreasing. All right, Zach. Velocity.
So that is back to like
Right. It's at a max and acceleration.
0.
Right, because we are at equilibrium, the x is 0, so force, the restoring force is 0. These always mimic each other. Alright, MK, what's going to happen once we hit equilibrium and we're headed, velocity is taking us past equilibrium, what will happen to velocity here? It decreases.
The middle, and then the one to the right. Increasing, increasing.
And acceleration. And lastly, Alex, looking at the pattern, we were at velocity at max, velocity decreases, and once we hit amplitude, what happens to velocity?
It is at 0.
Right? And acceleration,
It's at the maximum.
because it's furthest away, x is at a max, so therefore acceleration mimics what force is, so it is at a max as well. Alright, just for fun, let me check those answers. So, you can gaze upon their beauty for a second. Alright. Generally, when it comes to testing, you may not have to do every one of these 5